Today we're going to look at using the pipette head on Firefly. We're going to look through a few of the advanced properties of the pipette head. Let's do this by adding a copy step. The copy step properties are split into three main sections. The first general purpose section includes the description. This is where a step can be described to give the user more detail into what is happening in the specific step. If this is left blank, a default description will be generated. Source. The well array that will be aspirated from. In this case, we will assign the well array source. This asset can also be assigned by dragging and dropping the asset onto the step. Destination. The well array that will be dispensed to. Let's assign the well array destination here. Volume. This is the volume to be aspirated from the source and dispensed into each well of the destination. In this case, we will copy 10 microliters of liquid from the source to the destination. Now let's get into the detail of the liquid handling properties. Speed. This is how fast the liquid is aspirated into the tips, as so speed is required for more viscous liquids. The next two properties allow the user to define air gaps before and after the liquid is aspirated. Blowout volume is a volume of air to aspirate into the tips before the liquid is aspirated. This allows the blowout of any excess liquid at the end of the dispense, making for precise and accurate transfers at low volumes or with viscous liquids. Air transport volume. This is a volume of air to aspirate into the tips after the liquid. This is used to prevent droplets at the end of the tips when handling volatile liquids, for example, ethanol. It is important to remember that the air gap properties must be set for both the aspirate and the dispense. In this case, we will only look at the aspirate properties. The next property the user can define is the tip tracking properties. These properties control the movement of the tips within the wells during the pipetting step. Auto tracking. When auto tracking is enabled, this will automate the Z movement to keep tips at a constant depth beneath the liquid for the entire aspiration or dispense. This is done using pre-calculated start and end heights based on starting well volume of the well array and the total copy volume. If you wish to define specific heights, you can do this by unticking auto tracking and using the start height and end height properties. These can be used to set the height of the tips at the start and end of the aspiration or dispense. Now let's look at tip tracking offset. This allows the user to control the depth the tips are below the liquid surface. This should be 0 if auto tracking isn't being used, to ensure correct start and end heights. In this example, you can see auto tracking on the left-hand side and a defined start and end height of 95% on the right-hand side. The final property is tip touch. These properties control the movement of the tips during a tip touch after the specified pipetting step. A tip touch is used to help remove any droplets attached to the tip. Tip touch method. This property allows the user to select which position a tip touch will be performed. A surface tip touch uses the pre-calculated end height to have the tip touch the surface of the liquid. A side tip touch, such as left-right, is when the tip touches the side of the well. This can be just once, such as a left tip touch, or up to 4 times with a left-right front-back tip touch. A left-right tip touch is added by default to the dispense to ensure clean tips at the end of a transfer. Finally, tip touch height. This property is used to define the Z height of a side tip touch. This is calculated from the top of the well and will depend on the volume of the liquid in the well. As we only have 10 microliters copy volume, the tip touch can happen slightly lower down the well if necessary.